if you can't just see what it is right away, or if you want to convert it using unit analysis, if you want to get rid of millimeters, you got millimeters on the bottom. If you want to turn it into centimeters, you put centimeters on top. And then you put how those two are related to each other. 1 centimeter is 10 millimeters. This is exactly what we just did, where in that warm-up you had to multiply 7 over 3 times 15. You can cancel the 15 and the 3 to make it a 5. Here it's even easy because one of them's a 1. If you have 205 times 1 divided by 10, you just do that. Times 1, you don't even need to do anything. Divide by 10, you get your 20.5. It's a way of knowing that you've done it right, because if you have millimeters on the bottom and millimeters on top, those cancel out, and you're left with just centimeters. So that's where that comes from. You don't have to do it by unit analysis, but you should know how to use unit analysis, especially when we start to work with the imperial system. If you have 0.06 meters, that's a small fraction of a meter. Probably something better is centimeters. If you can't see what it is right away, 0.06 meters. I have centimeters, I have meters. Which one do I put on the top? Which one do I put on the bottom if I'm using unit analysis? What do you think? Well, let's think about this, because we want we always put the bigger one on top. If you want to get rid of meters, where do you put it? On the bottom, because we want to be able to cancel it. We want to be able to cancel the meters, so you put it on the bottom, you put the centimeters on top. Then you fill in the numbers. How are those related? One of them is equal to a bunch of the other one, right? 1 meter is equal to 100 centimeters. So then you know you need to go 0.06 times 100. You don't even need to do divided by 1 because it doesn't change it. So that's a way of knowing you need to multiply by 100. I know some of you are sitting there saying, this is way more complicated than it needs to be, because I know that all I need to do is multiply by 100 to turn it into centimeters. I'm happy if you know that. That's good if you know that. It's just that when it starts to be more confusing, when the units are not so familiar to you, you can always have this to fall back on. Okay? The other one here. Like, it might not make sense to you whether you multiply or divide here. If we want to turn this into, what would be reasonable? Distance traveled between those cities? Not meters, right? We want to get rid of meters, so they go bottom, right? We want to keep, or we want to turn it into kilometers, you put those on top. What's the relationship? 1 kilometer is equal to 1,000. That tells you if the thousand's on the bottom, you know you need to divide. This number divided by 1,000. So it's going to give you 590 kilometers, right? Because our meters cancel out. I know you can probably just go 1, 2, 3 and count it off like that. The top of a door is 2,110 millimeters high. 2,110 millimeters. What might be a useful, what's the best measurement for height of a door in metric? You could do centimeters, you could do meters, you could do either one, right? If you chose centimeters, what you would be multiplying this by is 1 centimeter is 10 millimeters. How does that tell you whether you're multiplying or dividing by 10? The fact that the 10's on the bottom means you're going to divide by 10. If you wanted to turn it into meters, you could put a meters here. 1 meter. How many millimeters is that equal to? It's called milli because it's 1,000, right? And then you know you're dividing by 1,000. So you're either going to have 2.11 meters, or you would have 211 centimeters, whichever way you did it. Okay, you can decide which one's more useful there. There is a problem here that we're going to look at. Okay? A lot of this unit is learning to use the measurements, but a lot of it is the problem solving involved in that as well. You're going to need to remember how to work with circumference. I would draw a picture of this. I would like you to try and solve this first before we look at it together. Can you try and work with the person next to you to solve this problem and somehow show what you're doing? Draw a picture. When you're solving a problem, it's not instantly you're going to start writing some stuff out. You could probably draw a picture of it. That would help. I think it always helps, something visual like this. Label the picture. Somehow show what you're doing, right? Work, method, steps, I don't know. Come up with an answer, okay? The first step's going to be trying to understand what's going on here before you do anything. If you can approach a problem and think about what it's asking rather than saying, I don't know, how do we do these barrel questions, right? I'm not going to show you how to do barrel questions and then give you barrel questions to do. This is a problem maybe you've never seen before, but you can think about it, draw a picture, discuss with the person next to you. I'm going to pause this. So here's to recap. I want you to work through this question, and at some point we'll stop and we'll compare. Possibly right before lunch. That's likely what we're going to do. Once you and the person next to you feel like you've come up with some kind of a solution there, and I'll help you individually, right? Then you can start to work on this. Can you write this down right now? I'm going to give you a sheet to keep track of assignments for each unit, but for now just write it at the bottom of that handout. And then that's our plan for the next half hour or so. One thing to realize is all the answers for all the questions in that book are in the back. Please don't, if I ask you to hand in your work at some point, I really don't want your work to look like this. This is not grade 8 anymore, right? This is grade 10. We know how it works. If you just say 32 meters, number 4 is 76 centimeters, number 5 is 211 millimeters. This is nothing, right? The answer you can get from the back, you're trying to think of this as you're trying to show me that you understand. I might be using this to assess whether you understand. If this is what you show me, I have no clue whether you understand, to be honest with you. I'm not saying you copied it out of the back, but this doesn't show me anything, right? Put down some kind of part of what we're working on here is learning how to show what we're doing. You may not know how to show what you're doing. Put some words down. Explain. Put something down. If this, I'm trying to convert it. It doesn't have to be that you're showing your work exactly like I did up here. You could do it your own way. You could say 1,000 millimeters is 1 meter. Therefore, I divide by 1,000. And put your answer. You don't have to show things the way I showed it. I don't want to teach this course where you're just regurgitating steps I showed you. I want you to write down some logical steps and logical explanations as you do things. So your work is never going to look like this. But it might look like words, it might look like steps, it might look like whatever. You are working on how you communicated it. And as we do this, we're going to compare and get some feedback from others on how we communicated it. I want to give you enough class time to do this. So 2 things. Everybody's okay? Thing number 1 is work on example 3. Thing number 2 is get started on those questions.